All right, okay. So what do I have in plastics?
Petroleum.
Okay, can. Okay, what in petroleum some more? But petroleum is beforehand. What is before, after I make the plastics? What is in, okay, what is in petroleum? If you think, huh, what is in petroleum? You all don't know, isn't it?
Don't know, teacher.
No, teacher.
Okay, good. So in plastics, I have something called polymers. Okay, so all these plastics are made from polymers. For example, PVC and everything. Okay, Irfan came in. Okay, now polymers. So these polymers actually consist of carbon compounds. Okay, teacher has polyethylene. Okay, so C4, C2H4. Can you see the carbon compounds here?
Yes, teacher.
Okay, so even a rubber eraser, it is made also from carbon. Okay, what is the carbon that is made out from? Okay, if you look at the eraser, it is actually made from isoprene. And isoprene is actually 1,3-butadiene. What on earth Puan Shina is talking about? Okay, this is what I'm talking about. Okay, 1, 2, 3. Okay, this is your carbon compound. So can you see I've got carbons here in a rubber eraser? Can see or cannot see?
Yes, teacher.
Okay,
Yeah, I can do.
all right. And then the last one is I have paper. Because we're thinking, teacher, how come paper? All right. Uh, what is the how come paper got carbon? Now, if you remember, paper comes from where? Where do paper come from?
Trees.
Okay, paper comes from trees. Now, if paper comes from trees, is tree a living thing or
Yes,
non-living thing?
Yes.
Can you
Yes.
hear me?
you're lagging a bit, teacher.
Yeah, I know. I'm so sorry.
Nah,
Okay. Now, trees, they are organic compounds. Okay. And if you look at a tree, if you look at human, you look at the tree, you look at everything, they all have carbon compounds. They will all have. There's like a plant here, it got carbon compound. A tree also has a carbon compound. Okay. Now, I think you all are very clear now about carbon compound, right?
Yes, teacher.
Okay, I go to the next page. Don't worry, teacher will share with you the slide. Okay, so if you look at this carbon compound can either be two things. The carbon can be carbon and hydrogen or carbon and hydrogen with other things. So I'm going to separate this into, okay, a carbon compound can either have carbon and hydrogen, or the carbon compound can be carbon, hydrogen, oxygen, nitrogen, sulfur, and any halogens. Okay? Wait, things are going missing. Okay, and any halogen. So I put chloride lah here. So as long as my carbon is reacting with oxygen, nitrogen, sulfur, phosphorus, and or either chlorine or halogen, these can be called as carbon compounds. Carbon can be attached to hydrogen, but carbon can also be attached to all of these as well. So two types. Are we clear?
Yes, teacher.
Okay, so this CH has a special name actually. I call it hydrocarbon. Teacher, why hydrocarbon? Because only got carbon and only got hydrogen. This one is not a hydrocarbon. Why, teacher, not a hydrocarbon? Because got so many others. Got Chongsperkol. Okay, this name. Okay, now, so from just now, I told you I got organic compound. That organic compound, okay, sorry, the carbon compound just now is teacher dividing it into an organic compound and an inorganic compound. Okay, one is organic, one is inorganic. Okay, how to differentiate? Very simple. Teacher already did for you here. Chemists define organic compound as carbon containing compounds. So as long as that organic compound has carbon, okay, it will be called an organic compound. Example, carbohydrates. Example, proteins. Example, fat, enzymes, hormones. All these are called as organic compounds. Now our food also is got glucose, right? So it's also an organic compound. Fuel, like I told you just now, butane, C4H10. It is also an organic compound. Wood, in our wood, our trees also, it is an organic compound. Okay, teacher want to ask you, this organic compound, if they have carbon, are they ionically bonded or covalently bonded?
Ionic.
Okay, if they are, okay, so you must remember again, carbon, carbon, what is my proton number? Carbon's proton number is 6, correct?
Yes, teacher.
Okay, if the number of proton is 6, my number of electron is also
6.
6,
6. So if teacher want to draw the electron arrangement, 2,
2, 6,
no, cannot be 2, 6.
2, 4.
2,
2,
4,
4.
sorry.
1,
2 for 2.
2, 3, 4. Okay, so it's 2, 4. Now, if it is 2, 4, okay, do you think carbon will donate electron for ionic compound or will it share electron? 2, 4, 2,
Share.
4. We
Share.
share or we donate?
Share.
Yeah.
Very good. 4 must share. So I give you an example. If teacher put hydrogen here, okay, share one here. If I put another hydrogen here, I share this one. If I put another one here, hydrogen, I share. Sorry, teacher got no space here, but just have a look what teacher is doing. And I share another one here. So can you see that now this carbon at two more people are coming in, but I don't know who they are, ZA. Okay, if you look properly here, can you see they're all sharing electrons here? Can you see the diagram teacher just drew? Can you see they are sharing electrons?
Yeah, teacher.
Okay, so
Can, teacher.
an organic compound is a covalent bonded compound. Okay, it is not ionic, it's covalent. Okay, does that make sense to you?
Yeah, teacher.
Okay. If everybody is okay with this page, I'll go on. But there are some exceptions. Some of that is not, yeah. Some of that is not an okay. Some of them, even though they got carbon, but they are not an organic compound. I've got 4 types. Remember, anytime you see a carbon, but the carbon has oxygen, that is not an organic compound. For example, carbon monoxide, carbon dioxide, okay, that is not, okay, that is not organic compound. Following, teacher?
Teacher, can you repeat that again?
Yes,
Okay.
teacher.
Yeah, before that, I want to ask, who is Za and who is Z in the group? Who is Za?
I think Z is Awari.
Who is Za, please? Yeah, but who is Z?
What is
We don't
our
even know.
teacher?
Both is
So,
Awari.
Zawawi. Okay, Zawawi. Okay. All right. So I
Both is
repeat.
Zawawi.
Okay, I repeat what I just said. Yeah. Teacher said, we know just now, whenever you see a carbon compound, if that compound got carbon, we say, oh, straight away, this compound got carbon, therefore it's organic. But ada pengecualian dia. There are some exception. If you see a carbon with the oxide, like carbon monoxide and carbon dioxide, tell me class, carbon monoxide, carbon dioxide, do you think it's an organic compound?
No, sir.
No, cannot. So this is the pengecualian, this is the exception. Walaupun dia ada carbon, even though they have the carbon, but no, it is not organic compound. Okay, so this is rule number 1. Rule number 2, even though I have a carbon here, okay, but if it's a carbonate, okay, can you see this is a carbonate here? All of you can see?
Yes.
Okay, even though it is a
Yes.
carbonate and there is a carbon here, it is not an organic compound. Not. Whenever you see a carbonate, you cannot come and tell, teacher, carbonate, got carbon there. It is an organic compound. No. This is the pengecualian. Cannot. Carbonates are not organic compound. So if teacher tell you, class, magnesium carbonate. Yes, I got carbon. But is it an organic compound?
No.
No, it is not an organic compound, even though I have carbon. Are we clear?
Yes.
Okay.
Yes,
Yeah,
sir.
sure.
Now another thing, hydrogen carbonate. See, I have carbon here, teacher. I got carbon, what? It should be organic, what? No, I'm so sorry, it's not. If you see any hydrogen carbonate, same thing lah, the word carbonate. Sorry, it is also not an organic compound, even though it has a carbon. And the last one, if you see a cyanide, teacher, how I know what cyanide is? You see Chinese New Year, you can already, Chinese New Year, got the year went missing. When you see CN, it's called cyanide. Anytime you see the word cyanide, got C here, what? Teacher, got C here. Why is it not a carbon organic compound? No, cannot. This is not an organic compound. Okay, these are the exceptions. So it is not an organic compound. So 4 examples I gave you of it is having carbon, but it is not an organic compound. Are we clear?
Yes, teacher.
Okay, simple. Okay, if it is not an organic compound, teacher, then what is it? If it's not an organic compound, what can it be? Okay, so we call it inorganic compound. Okay, inorganic compound has all the all has the non-carbon containing compound. Okay, they don't have any carbon at all, or they have very few carbon containing compound. Very, very few. Okay, and how do I know it's a inorganic compound? Normally got very beautiful colors. Look at the example here, copper 2 sulfate. A nice blue color, right?
Yes.
So that is an inorganic compound. Okay, another one will be sodium chloride. Okay, white in color. Okay, so that will be an inorganic compound. Okay, why is it inorganic compound, sodium chloride? Can somebody tell me? Why is sodium chloride an inorganic compound? Someone tell teacher. Ismo just coming in.
By the outside.
Sorry? Not hear you. Why is sodium chloride an inorganic compound, not an organic compound?
Because it's non-carbon
Very good. Sodium chloride, I cannot see any carbon. Boliau carbon, tak ada carbon. That's why I call it inorganic compound. Understand?
Yes, teacher.
Yes, teacher.
Okay,
Yes, sir.
I'm going slowly for y'all, yeah? So the basic y'all can understand. Okay, let's compare organic and inorganic. Okay, you can also find this in your textbook, the one I gave you, page 65. If you haven't printed it out, never mind, you can look at my screen, okay? All right, now let's look at protein. You tell teacher. Protein got carbon, got hydrogen, got oxygen, got nitrogen. Okay, is it organic or inorganic?
Organic.
Organic, obviously, because I got a
Organic,
carbon.
sir.
Here, because got carbon. Carbohydrate, I got
Yeah,
C, I got
carbon.
H, I got O. Is it organic or inorganic?
Organic.
Organic.
Organic because of carbon.
Organic.
Very good, because got carbon. So the key thing teacher wants you to remember today is organic must have carbon, yeah? Okay, look at alcohol again. I got C, I got H, I got O. What do I need?
Organic.
Organic because of the carbon. Chloroform also
Then,
I got C.
Ink.
Polystyrene also I got C, carbon. You know the
yeah.
polystyrene cup, polystyrene styrofoam that we used to eat. All these are also organic compounds. Okay, now let's look on the other side, inorganic. Okay, silica and oxygen. Silicon and oxygen. Do you see any carbon here?
No.
No, there is
No.
no carbon. That's why it's called inorganic. Now look at marble. Marble is actually calcium carbonate. Even though I have a carbon, why is it not why is it not a
Lighting.
sorry?
Not oxygen.
Why is it not carbon? Why is it not organic for marble?
Oxygen, teacher.
Not because of oxygen only, because of the carbonate.
There's no carbon. Yeah.
Got carbon, but because the carbonate
Carbon.
makes it inorganic. Okay, now if you compare these three, okay, teacher don't want to waste time. This one memang tak ada carbon, tak ada carbon, tak ada carbon. Okay, faham?
Yes, teacher.
Faham.
Okay. Okay, this one pernah keluar in SPM 2017. Betul-betul soalan ni. Okay, betul-betul same soalan. Okay, this is the combustion of organic compounds. Okay, organic compounds must have carbon. So memang ethanol kat sini. Teacher help you. Ethanol is C2H5OH. Okay, we heat up the ethanol. Okay, we want to see what is going to happen in this experiment. Okay, everyone here following teacher?
Yes.
Okay,
Yes,
so
teacher.
let's look at the experiment. So what do I have? I have ice, I have ethanol, I have palm oil. Later teacher will replace with palm oil. I got lime water. I got water also here. Okay, water is inside here. Okay, teacher first put a spirit lamp. This is called a spirit lamp. I put in with some ethanol. And then teacher set up the apparatus like this. The spirit lamp is lit up because I want to let the ethanol burn. Okay, after it's burning, I will turn on the filter pump. Okay, I turn on the filter pump. I want the air bubbles all to come out. Okay, and then what I'm going to see is I am going to see the changes that takes place in my boiling tube A and my boiling tube B. After 15 minutes, I turn off the filter and boiling tube A, I remove it. I take out the boiling tube. That means all the liquid that is coming from here will go inside here. Okay, all the water that is here, I take it out, I take the liquid and I heat it up until it starts boiling. When it starts boiling, I will record it. I will record the boiling point of the liquid. Okay, and teacher repeat this experiment using palm oil. Okay, you tell me, class, what do you think is in that boiling tube A? What do you think will come in the boiling tube B? What do you think? Okay, before that, Lakshman, can you put in the name list, Lakshman?
Okay, teacher.
Thank you. All right. All right. So class, you tell me. You look at the procedure also, I can give you some hint. See, they told me, check the boiling point of this liquid, boiling point of the liquid. Cartesian came in. Okay, and then here I'm testing with lime water. Okay, before I give you the answer, who wants to be brave? When I heat up ethanol, what will I get?
Is it carbon, teacher?
Carbon. Hydrogen.
I didn't hear you.
Is it carbon dioxide?
Okay, carbon dioxide is correct. One of the side product. Another side product?
Hydrogen.
No. You see, a liquid is formed here, a liquid. Sorry, did someone say something? Okay, actually the answer is water. Okay, I'm going to get water. That's why they ask you to test the boiling point of the liquid. When I test the boiling point and if I get 100 degrees Celsius, therefore I know water is formed here. Okay, let me show you what is happening. Ethanol, C2H5OH, reacting with oxygen, any carbon compound, anything. Okay, I'm going to teach you in this chapter, anything when react with oxygen, I am going to get water and carbon dioxide. Are we clear?
Yes, teacher.
This process, I call it combustion. Okay, chapter 2 is a lot about memory. If you like to memorize, you will love this chapter. Did you love this chapter? One of my favorite chapters. But I think I say that for all my subjects, right? All my topics, right? Correct?
All chapter, teacher.
Okay. I'm lagging. Is it very badly lagging?
Yeah.
Yes, teacher.
Teacher.
Not bad.
Very bad or how?
Yeah, you're still lagging, teacher.
Bad. Very bad.
I'm so sorry. I am very, very sorry.
Hello, teacher. Yeah,
Hello?
you're lagging.
Teacher lagging again.
Yeah, you're lagging.
Yeah, teacher.
Can you see me
Teacher.
doing funny
Doing
You're gonna
faces?
get stressed lah.
Can you all see me doing funny faces?
No, teacher. Yes. Oh, yeah.
Yeah, again, teacher.
Yeah.
You're
Can
like
you see?
You're also
teacher.
lagging, teacher.
Oh my gosh. How?
Like Minecraft only teacher face.
I stop sharing first. How can cope? Did you understand what I've been saying so far?
Yes, yes.
Yes, sir.
Yeah,
Can,
teacher.
teacher.
Can, I don't know what my son did. Okay, I think he must have played with some filter. My picture looks so good here. Don't know what filter he put. I look super fair, super flawless. Okay, I think something wrong. Okay, must go and ask him what he did. All right. Anyway, can I continue? Am I still lagging? Am I still
Not
lagging?
really. Sometimes, teacher.
Yes, something.
Okay, so teacher continue, yeah?
Sometimes.
Yeah.
Can you all
Okay.
scream? I got 10 teachers talking around me.
Can, teacher.
Can, teacher.
Can, teacher.
Okay. Wait up. Okay, teacher was here, right?
Yes. Yes, sir.
Okay, so, and then from my observation, I saw that, oh, it's boiling at 100 degrees Celsius. And then here, my lime water turns milky. So obviously, my inference will be carbon dioxide is produced here, correct?
Yes, sir.
And my colorless liquid in boiling tube boils at 100 degrees Celsius. What will this be?
Yes, yes.
Why
Water.
yes, water. Okay, all right. So what is the point here? My point is when I burn any organic compound in excess oxygen, I am going to get carbon dioxide and I am going to get water. Are we clear about that?
Yes, teacher.
Okay, so complete combustion, okay, produces carbon dioxide and water. So after this, don't tell teacher, I didn't know that. Okay, I'm telling you now. Whenever you have combustion, you must get carbon dioxide and water. Okay, everybody register that.
Yes.
Yes,
teacher.
sir.
Okay, now let's test. See whether you pandai ke tak pandai. Okay, first one, propanol. Is it an organic compound or inorganic compound?
Organic compound.
Okay,
Again.
organic compound, pandai. Lead to carbonate, organic ke inorganic?
Inorganic.
Inorganic, pandai anak cikgu ni. Ethanoic acid, organic ke inorganic?
Organic.
Organic.
Organic. Carbon dioxide,
Organic.
Inorganic.
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 Glucose,
Organic.
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 organic compound. See, y'all are super duper clever children. Okay, very clever. Okay, now,
Teacher, you're lagging.
okay,
Teacher, your super effort taking so long, teacher. The lagging.
Yeah, you're
Lagging,
lagging.
teacher.
now still lagging. Oh my gosh.
Teacher lagging.
Now.
Teacher, you're lagging.
You're lagging.
Yeah, confirm using school Wi-Fi.
No, I'm using my Wi-Fi. School don't have Wi-Fi today. Can you imagine? Wait,
Oh,
am I still lagging now? Am I? No, no,
No.
okay. All right.
Just a bit, yeah.
Now, quickly, I do very quickly hydrocarbons. What time's your next class? 12, right?
Not sure, teacher.
12:30, teacher.
But my class with you ends at 12, right?
Hello.
My class with you ends with
Yes,
at
sir.
12,
Yes, sir.
right?
Yes, sir. Yeah.
Okay. Half an hour to bear with me, okay? Thank you. Okay. The simplest organic compound. So teacher, I'm going to draw for you a mind map. Okay? We start with carbon compound. This carbon compound divided into two, organic and inorganic. Okay, now this organic now teacher going to divide into two again. Hydrocarbon and non-hydrocarbon. Okay, can teacher move on now?
Teacher.
Okay, so hydrocarbons are the simplest organic compound, just like our body. What's the smallest thing in our body? Cell, right?
Yes.
Yeah.
Okay, in an organic compound, the simplest thing that I can find is called a hydrocarbon. The simplest thing is a hydrocarbon. Pernah keluar in exam before definition. Define hydrocarbon. So hydrocarbon, they are organic compound. See how it's going back here to organic compound that has carbon and hydrogen only. In exam, if you don't put the word only, you don't get any marks. Okay, can you understand, teacher, so far?
Okay, teacher.
Lagging again.
Okay, laggy.
Lagging.
Lag. Huh?
Lagging?
Yes, sir.
Lagging je.
Lagging, teacher. Yeah.
Yes, lagi.
Teacher, you have to repeat the sentence you say, teacher.
Okay. I said. So funny lah. Better teacher work from home, right? Must go and complain lah. Okay, hydrocarbons are organic compounds that has carbon and hydrogen only. Must have the word only. If you don't have the word only, 0
Okay.
marks. Clear?
You go lagging
Just
again.
started lagging again, sir.
Okay, teacher.
Now better? Can hear me? Can you hear me? Can you hear, teacher? Oh, I off the camera. Okay, wait.
Hello.
Hello?
Teacher lagging.
Wait, I off my camera, wait.
Teacher. Better.
No teacher, lagi.
Still lagging.
Still lagging up.
Yes.
Yeah, can, teacher.
Now can je.
Now can? Okay, wait.
Yes.
Can
Yes,
Wait,
teacher.
ah.
Can
Yes.
Can,
teacher.
teacher. Can.
Okay, wait. Now, can you see? Hello?
Can, teacher.
Yeah, check in here.
Yes.
Okay. Sorry, had to lepaskan the geram.
Lagging.
Huh? What? Lagging, is it?
Okay, teacher. Now can hear. No, now you are clear, teacher.
Okay or not okay now? Can I continue?
Now okay, now okay.
Now okay, teacher.
Oh, yo. Okay, let's go on. All right. It's okay lah. We smile at every situation. Okay, you all can't see me smiling also. See my Tom and Jerry there. Okay. The hydrocarbon is an organic compound that has carbon and hydrogen only. Okay, that is hydrocarbon. It's so obvious also. You look at the name. Hydro for hydrogen, carbon for carbon. So I must have carbon and hydrogen. Now teacher want to ask you, the carbon and the hydrogen here, you tell me, are they covalently bonded or are they ionically bonded?
Covalent.
Very good. How? Teacher, how do you know it's covalently bonded? How do you know?
They
Copy,
share.
sharing.
Very good. Okay, they are covalently bonded because they are sharing electron. Very good. Next, you look at my C and my C. Okay, are they covalently bonded or are they ionically bonded?
Ionically.
Huh? Ionic or covalent? Okay, again, it's covalent. Why? Because they are sharing electron. See,
Sharing,
they are
yeah.
sharing. So again, C and C, they are covalently bonded because they are sharing electron. Okay, so far so good.
Yes, teacher.
Okay, so if you look properly, okay, hydrocarbons, they are organic compounds. Look at hydrocarbon here, they're organic compounds, okay? And they only have carbon and hydrogen. Okay, now let's look at an example, okay? Let's look at example. Teacher put here CH4. Okay, teacher put here CH4, but I think I will change it to to change to C2H6. Okay, how do I draw C2H6? Okay, 1, 2, and one carbon must have 4 bonds. So I need to now put in my hydrogens, right? So I'm going to draw 1 hydrogen here, 1 hydrogen here, 1 hydrogen here. And then for the other one, I'll get 1 hydrogen here, 1 hydrogen here, 1 hydrogen here. Okay, now let's see. Is it correct? I got C2. Do I have 2 C's?
Yes, sir.
Yes.
Yeah.
Do I have 6
yes.
hydrogens? 1,
Yes.
2, 3, 4, 5, 6. So yes, it is correct. Okay, yes, it is correct. Okay, now if you notice, and you must always remember, one carbon must always have 4 wives. Okay? One carbon must have 4 wives. So you look at this carbon here. Sorry, teacher got a message just now. I was looking at it. Okay, look at this carbon here. Okay, look on top. I got wife number 1 here, wife number 2 here, wife number 3 here, wife number 4 here. I must always have 4 wives. I must always have four. I must always be bonded to 4 things. Why? Because carbon is C2.4, correct?
Yes, sir.
Yes,
Okay,
sir.
how many more to become stable? 4 more to
4.
become stable, right? That's why I must always have 4 bonds. Okay, I must always have that 4 bonds because then I will get 8 valence electron. Can you understand?
Yes, sir.
Yeah, I'm trying to scream and shout here. 10,000 teachers talking to me. Talking around me, sorry, not to me. Okay, so if you look at the hydrocarbon, okay, all these are single bonds. See, all single bonds. Another one here, so all single bonds. But if you look at this one, is it a single bond or a double bond?
Double bond.
Double. And then this one, what do I have?
Triple bond.
A
Triple
triple bond.
Triple.
So hydrocarbon, I can have single bond, double bond, triple bond. Okay. All right. So I again draw for you the mind map. I start with carbon compound. Carbon compound divided to organic compound and inorganic compound. Organic compound divided to hydrocarbons and non-hydrocarbons, correct?
Correct.
Yes, sir.
Okay, non-hydrocarbons. Okay, now hydrocarbons I divided into saturated and unsaturated. Okay, saturated and unsaturated. Now, when saturated, okay, look at the word satu. Satu means what? 1, isn't it?
Yes, sir.
Okay, that means that hydrocarbon has only single bond, only 1 bond. So you look, all 1 bond only, 1 bond, all have only 1 bond. Can you understand?
Yes, teacher.
Okay, that is the meaning of saturated. Okay, the hydrocarbons has only single bond. But when you see the word unsaturated, not 1. Okay, unsaturated means not satu. Okay, that means it must have double bond, triple bond. Okay, for example, look at this here. Can you see a double bond here?
Yes.
Yes.
So here I have got double bond, unsaturated, double bond, triple bond. This one saturated, I got single bond. Okay, so what is the meaning of saturated? They are entirely of carbon-carbon single bonds. Must have the word carbon-carbon. Okay, carbon-carbon single bonds. That means my carbon and my carbon here is a single bond. Okay, it's called a single covalent bond. Any questions?
I know, teacher.
Teacher.
Okay. Now, unsaturated, they must have at least one carbon-carbon double or carbon-carbon triple bond. It's carbon-carbon, yeah? Not carbon and hydrogen, not carbon and oxygen. It must be carbon-carbon double bond, carbon-carbon triple bond. Okay? Where can I find hydrocarbon? I find it in petroleum, in coal, natural gas, in trees. Okay, rubber trees also, I can get my hydrocarbon there. Okay, then, Puan China, you say hydrocarbon. What is non-hydrocarbon? Okay, non-hydrocarbon is when the hydrogen atoms has been replaced with anything like oxygen, nitrogen, phosphorus, or halogens. For example, sugar. We know sugar is C6H12O6 glucose, right? Can you see
Yes.
I got oxygen here?
Yeah, sir.
So is this a
Yes.
hydrocarbon or a non-hydrocarbon?
Non-hydrocarbon.
Okay, non-hydrocarbon. Because I not only have carbon and hydrogen, but I also have oxygen. Does it make sense to you?
Yes, sir.
Okay, now look at protein. Protein also is a organic compound, but it is a non-hydrocarbon because, okay, it has carbon, hydrogen, oxygen, and nitrogen. So I got oxygen here and I got nitrogen here. Are we clear?
Yes, teacher.
Okay, next one, tetrachloromethane. I have carbon, but I have Cl. So it cannot be a hydrocarbon. It is a non-hydrocarbon. Okay? Okay, never mind. Okay, I want you to look at this and then I want you to answer with teacher. Okay? I want you to write this question down. All of you take out the test pad. Write down the questions. All of you, yeah?
Okay, teacher.
And finish already?
No, teacher.
Okay, try to answer. Teacher give you 1 minute to answer. Okay, finish? All right, written down, ready? Okay, who wants to try for me the first one? A compound that contains carbon element. What is the name of it?
Organic carbon.
No, wrong.
Carbon compounds.
Carbon compound. Okay, this answer here is carbon compound. Good try though. Zawawi, good try. Okay, now the next one, B, hydrocarbon only having single bonds.
Saturated.
Okay, very good. Saturated. Okay, saturated hydrocarbons. Okay, all right. Let's have others also trying. Okay, organic compounds containing only carbon and hydrogen. Only got these two.
Hydrocarbon.
Hydrocarbon.
Very good, very good. A hydrocarbon. Okay, another person. A carbon compound that they come from living things.
Organic compound.
Organic carbon.
Yes, okay, good job. Organic compound. Okay. Now, if you have double and triple bonds, another person, yeah?
Unsaturated.
Dinesh, yes, Dinesh?
Unsaturated.
Okay, unsaturated
Hydrocarbon.
hydrocarbons. Okay, all right. So interesting, right?
Yes, sir.
Okay, actually the other part is very long.
Yeah.
I think I will keep it for my next class with you. What is this? When is my next class with you all? Monday, right?
Yes, sir.
Yeah.
Okay, your brain still can compute or cannot really?
Can.
Can, teacher.
Can, teacher go a bit more, then we don't waste time, can or not?
Okay,
Can,
teacher.
Yes, yes, yes.
Okay, so the main, like just now, I think Lakshman said, where do we get our hydrocarbons from? Good, he answered very well. Plastics, it comes from petroleum actually, natural gas, and even coal. Okay, today teacher will talk to you about petroleum. Okay, petroleum is actually a very dark, vicious looking liquid, found at the depths of the earth or the seabed. Okay, normally I can find it with natural gases, okay? And these natural gases usually have methane, not so very good for our body. Now, how do we get petroleum actually? Millions of years from the decomposition of animals and plants, okay? The bacteria will decompose these animal and plants and make them into a liquid form, okay? So what is actually in the petroleum? Okay, they are a mixture of all kinds of alkanes. They've got very great size and structure, okay? And many useful products are formed when I refine petroleum, just like Maggi mee. It just got Maggi mee here actually. Can you see my Maggi mee here?
Lagging, sir. Open.
Yeah, teacher. Can.
Can,
Okay,
can,
my
sir.
Maggi mee. Now, if I have this Maggi mee and I want to eat it now, no use. It's not cooked, correct or not?
Correct.
Okay, what do I need to do to this Maggi mee?
Oh, hot
Or
water.
hot water.
Pour hot water, mix everything together, then only it will function. Petroleum is also like that. I have petroleum by itself, no point. Really no point. I'm going to off my video because then I will not lag, yeah? No point. I need to refine my petroleum. Okay? Okay, let's see. Actually, I have how to refine petroleum and why must we refine petroleum. I want to convert this petroleum to useful products. Two process. The first process is the primary, of we call it fractional distillation, okay, where the hydrocarbon is separated according at different temperatures according to the sizes. If they are smaller in size, okay, they will actually become gases and they will move up in the distillation tower. Okay, a teacher got a YouTube link for you all. I don't know whether we have time to watch it. Okay, but if they are heavy, they will go down in the distillation tower and they will be separated differently. If you have your textbook with you, it is on page 67. Okay, the next step also is cracking. When I have the long chain hydrocarbon, okay, I don't want long chain, no point, no use. I crack it into smaller molecules, but I must use a catalyst. Okay. Do you think we can watch the refining process now? Let's try and see. See whether lagging or not. Can you see? Can you hear?
In this video, you will
Can you
learn
hear?
how
Second.
Can hear each other.
If I see.
fractional distillation separates crude oil into useful fractions. Crude oil
This
is
is
the
petroleum,
term
yeah?
video,
used to describe unprocessed oil. That is oil that has been taken directly out of the ground, either on land or
Can you
under the
hear?
sea. It is an
10 seconds.
exceptionally valuable resource.
Oh, sorry.
It provides us with a great number of hydrocarbons, some of which are useful as fuels, and others are used in the manufacture of many different chemicals and even plastics. However, in the raw form as crude oil, it can be a viscous, dark-coloured tar-like consistency, and the different fractions of hydrocarbons must be separated by fractional distillation for them to be useful. Before we understand how fractional distillation works, we should be clear that crude oil is a mixture of hydrocarbons with different chain lengths, some being short molecules and some being very long. Intermolecular forces act between molecules, and the longer the molecule, the greater the intermolecular force. As you can see here, the small molecules have weaker intermolecular forces, and so will require less energy to break them apart and turn them into a gas. They have a lower boiling point. The longer molecules have greater intermolecular forces. More energy is required, a higher temperature will be needed to evaporate these molecules. They have a higher boiling point. Now we understand how chain length is related to the boiling point of a molecule. Let us look at how this method works. As you can see, crude oil is heated up to a high temperature outside of the fractionating column. The hot crude oil, now mostly in vapour form, is pumped into the column. The column has a heat gradient and is very hot at the bottom, going cooler as we move up to the top. Even at the very bottom of the column, where the temperature is still high, some long chain molecules with high boiling points begin to condense back into a liquid. These are collected at the bottom of the column. The rest of the molecules start to rise up the column, making their way through bubble caps in each tray. The bubble caps slow down the rate of the rising vapour, and eventually the vapours get too cool, condense, and are collected as liquids in the trays. Small molecules have low boiling points, and so condense much higher in the column, where the temperature is cooler still. As you can see, hydrocarbons with similar boiling points are collected in the same tray, and this is why they are known as fractions. They are mixtures of hydrocarbons with similar boiling points. Each fraction has some important use.
You cannot see the video.
Cannot.
Why now only you're telling?
Actually, we told in the beginning, actually.
Yeah, that's right.
Cannot hear you, darling. Wait. Wait, Ayo, I'm watching myself. I wasn't looking at the... Never mind, teacher, y'all cannot see at all, is it?
No, teacher.
No, only can
Why?
hear, Jay.
That's
Only
why I'm
can
enjoying
hear.
myself only. Why didn't mention earlier? Okay, I try one more time. Okay, please say quickly whether you can see or cannot see. Can you see now?
Yeah, can, Jay.
Now only can see, teacher.
Okay, ayo, my
Cannot,
dear
can.
wonderful children. For 4 minutes, what were you all doing?
In this video, you will learn how fractional distillation separates crude oil into useful fractions. Crude oil is the term used to describe unprocessed oil. That is oil that has been taken directly out of the ground, either on land or under the sea. It is an exceptionally valuable resource. It provides us with a great number of hydrocarbons, some of which are useful as fuels, and others are used in the manufacture of many different chemicals and even plastics. However, in the raw form as crude oil, it can be a viscous, dark-coloured tar-like consistency, and the different fractions of hydrocarbons must be separated by fractional distillation for them to be useful. Before we understand how fractional distillation works, we should be clear that crude oil is a mixture of hydrocarbons with different chain lengths, some being short molecules and some being very long. Intermolecular forces act between molecules,
Can see or
and the
not?
longer the molecule, the greater the intermolecular force. As you can see here, the small molecules have weaker intermolecular forces, and so will require less energy to break them apart and turn them into a gas. They have a lower boiling point. The longer molecules have greater intermolecular forces. More energy is required, a higher temperature will be needed to evaporate these molecules. They have a higher boiling point. Now we understand how chain length is related to the boiling point of a molecule. Let us look at how this method works. As you can see, crude oil is heated up to a high temperature outside of the fractionating column. The hot crude oil, now mostly in vapour form, is pumped into the column. The column has a heat gradient and is very hot at the bottom, going cooler as we move up to the top. Even at the very bottom of the column, where the temperature is still high, some long chain molecules with high boiling points begin to condense back into a liquid. These are collected at the bottom of the column. The rest of the molecules start to rise up the column, making their way through bubble caps in each tray. The bubble caps slow down the rate of the rising vapour, and eventually the vapours get too cool, condense, and are collected as liquids in the trays. Small molecules have low boiling points, and so condense much higher in the column, where the temperature is cooler still. As you can see, hydrocarbons with similar boiling points are collected in the same tray, and this is why they are known as fractions. They are mixtures of hydrocarbons with similar boiling points. Each fraction has some important uses. Some examples of fractions are petrol, useful as a fuel for cars; naphtha, used in the manufacture of chemicals; kerosene as aircraft fuel; diesel oil, used as fuels for vans, cars and lorries; and bitumen, a mixture of large chain hydrocarbons used to lay roads. Now, at the end of this video, you should understand that crude oil is a mixture of important hydrocarbons, and that fractional distillation is the method used to separate crude oil into useful fractions with similar boiling point. You should understand that small chain molecules are collected at the top of the column since they have lower boiling points, and larger chain molecules are collected further down the column as these have higher boiling points.
Okay, did you understand that? Wait, did you understand what was shown just now? Hello?
Yeah, chair.
Yes, sir.
Yes,
Lagging.
sir.
Wait, I'm just trying to see. So long, I didn't use this. I also forgot how to use my... Okay. All right. Meeting controls. What are you seeing on your screen now?
Textbook.
Textbook.
Okay. All right. Did you understand what the teacher showed you just now?
Yes, sir.
Yes, sir.
Paham?
Okay. All right. I'm just going a bit more to finish. Just very, very, very. I think 1 or 2 more minutes then can be done already. Sorry, I was sharing with you my PowerPoint. Okay, so fractional distillation, faham, right? It's quite simple, isn't it?
Yes, sir.
Yes, sir.
Okay, so then besides fractional distillation, okay, I can use something else. Okay, the next step is teacher uses cracking. Okay, and then your question is, teacher, what is cracking? Okay, cracking is very simple. I have a long chain hydrocarbon. I crack it up into a smaller hydrocarbon. Okay, some of you likes to eat kacang, the hard kacang. How do you have to open the kacang? How do you open it? You crack it open, right?
Yes, sir.
Same thing. Okay, when I've got a long hydrocarbon chain, I cannot, it's not useful for me, the long hydrocarbon chain. I want to break it up. So I crack it. Okay, how do I crack it? I must heat it up at high temperature and pressure. What is my, so I use high temperature and pressure. Okay, high temperature. What else? My catalyst, I use aluminium oxide or silicon oxide. Okay, so silicon oxide or aluminium oxide. Okay, now what does the cracking do? The cracking actually produces smaller hydrocarbon. Okay, and an alkene with shorter chain, I can use it as a raw material to make polymers, medicine, detergent, solvent, fertilizers, and so much more. For example, let's say teacher have an ethene, C2H4, very small, or I have C20H22. C20H22, no function. Okay, it's too big. But this one, an ethene, I can make so many things. I can make polymers, I can make solvents, I can do so many things. And when I have a small size hydrocarbon, it can easily combust. That means I can react with oxygen easily to become fuel. When I have a long carbon chain, it will take a long time for it to combust. Okay, so this is the process of cracking. So teacher's showing you as an example here. I'll show you example 2. Let's count the carbon. 1, 2, 3, 4, 5, 6, 7. Okay, this is C7. Okay, how many hydrogens? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. C7H16, so long. Can I crack it? Yes, I crack it. I must have to, how do I crack? What are the 2 things I need to crack?
Carbon.
Anik? Class, what are the 2 things I need to crack?
Heat and pressure.
Heat and pressure.
Not pressure. Correct. I need a high temperature. What's another one?
Catalyst.
Very good. I need a catalyst.
Catalyst.
Okay, what is the catalyst teacher use?
Aluminium oxide.
Okay, aluminium oxide. One more. Silicon dioxide. Okay.
Silicon oxide.
So you see, now teacher got ethene. Teacher can make so many things with ethene. I can make robes. I can make plastic bottles. Pentane, I can use it for so many other things. More useful, I have a short carbon chain compared to a long hydrocarbon chain. Okay, that is the point here. Okay, teacher will stop sharing here. Okay, that is for today's lesson. Did you understand what teacher just taught you?
Yeah, sure.
Yes, sir.
Okay,
Yes.
if you understood, I want you to look at your textbook, page 70. Okay, textbook, page 70. I also want one person to take a photo of page 70. At the bottom there, got access 2.1. For chemistry, teacher wants you to have a file, yeah? A file, a simple file, very simple, and a lot of test pad. I'll be giving you a lot of test pad word. Okay, do you see page 70? Self-access 2.1. Let me see whether I can share it with you all.
And teacher.
You can see, right? I'm sure you can see, right?
And teacher.
Okay. Can you see this self-access 2.1 here?
Yeah, again.
Okay, everybody have to
Yes.
do this and hand it in to me by today.
All right.
Okay,
teacher.
you have to give it in to me by 10 o'clock tonight.
Okay.
Come on, teacher.
All right.
Okay, teacher.
Can we take a photo?
Thank you.
Sure, sure.
How to take a photo of all names only? Dinesh went for war. Huh? Okay, teacher is going to advise you. One of the main reasons why I want you to show camera is so that you can be accountable. You won't look at your phone. It's very easy to be distracted during class. Very easy. I'm sure if my phone is off, your video is off, you can do anything. I will never know, right? Correct or not?
Yes, teacher.
Okay. So I
Betul.
want you to be accountable. I don't know for other teachers' class, but for my class, if you're not using your phone, you're using the laptop. Okay. I want you to please make sure that you keep your phone one side. Then only you will not be distracted. Can we try that? Okay. If Azman doesn't mind, Azman, can you take the photo?
Yes, teacher.
Okay, wait. Okay, Azman.
Alright. Okay. 1, 2, 3. Smile. Wait, one more.
Do we have two
One.
pages?
Yeah, we got 2 pages. 1, 2, 3. Okay, then.
Thank you.
Welcome, teacher.
Bye, class. Karthik, finally see you,
Bye,
Karthik.
teacher.
Thank you, teacher. Bye, teacher.
Thank
Thank you,
you,
teacher.
class.
Yeah,
Bye,
bye.
class. It was
Thank
nice
you,
to see you all again today.
Nice to
You
see
too,
you,
teacher.
teacher.
Bye-bye.
Bye, teacher.
Bye, teacher.
Bye,
Teacher.
teacher.
Bye, teacher.
Bye, children.
Bye, teacher. Have a good
See
day, teacher.
you. I'm gonna end, yeah? Who's taking the recording, teacher? I'll send, okay? Wong, do you want me to send, Wong? Okay, Wong. Teacher will send. After this, yeah? Give me a few minutes, okay?